Hey, what's up everybody? In this quick tutorial, we're going to model a shoulder bolt. We'll start by creating a basic profile and doing a revolve, and then adding some of the more advanced features such as threads and the hex cut for an Allen key to tighten or loosen the bolt. Let's get started. To create our shoulder bolt, we're actually going to do a revolved boss base to create our basic shape. So let's open up a new part file, making sure that our units are set to inch, pound, second. And we're going to open up a new sketch on the front plane. And the first thing we're going to do is draw a simple center line. Like so. And we will double click. It's a neat little shortcut to end a line tool. Now we'll switch to solid lines and start drawing our basic shape. And we need one more line to close our loop. So now we're going to start adding some dimensions. The length of our bolt is going to be 1.784 inches. And the head diameter is going to be 0.438 inches. Now to capture the diameter for a revolve, what we're going to do is select the outer edge and select the center line. There's a little trick with SolidWorks where if you extend the dimension out like that on a center line, you can get a projected diameter. So we'll set that to be 0.438, and that messed with the profile, so we're going to hit escape to close out our dimensions, and we're just going to click and drag to get everything back where it should be. So that one should go there, and that one should go there. You want to try and maintain the basic shape of your profile as you're adding the dimensions. The length of our shoulder, which will be from the underside of the head to the start of our undercut, is going to be 1.125 inches, and the shoulder diameter is going to be 0.313 inches. Our undercut is going to have a width of 0.1 inch. I'll drag that back where it should be. And it will have a diameter of 0.190 inches. And our threaded portion will have a diameter of 0.25 inches because it's going to be a 1/4-20 thread. Okay. Now we need to set a dimension for the head width. So we will set that to be 0.219 inches. And our sketch is fully defined. I'll rearrange all the dimensions so you can clearly see them. Like so. Alright, Now that we have a fully defined closed loop, we will exit our sketch and create a new revolved boss base. And we'll keep the direction 1 set to blind with an angle of 360 degrees and hit OK. So now we have the basic shape of our part, and we need to start adding in the different features. The first thing we're going to add is some basic chamfers. So we'll go up here to where it says fillet, hit the drop down and select chamfer. For our chamfer depth, we're going to set it to be 0.015 inches, and we're just going to select the top edge, the underside of the head, the shoulder edge here, and the bottom edge of the thread. And we'll hit OK to create our chamfers. Now we need to create our thread, which is going to be a 1/4-20 thread. We have two options for doing our thread. We could do a cosmetic thread, where the thread is there symbolically but not graphically, or we could do a physical thread, where the thread is cut into the actual part. Now, each option has its own pros and cons. Cosmetic threads save us a lot in the form of memory resources, particularly if we're working with large assemblies. So if, for example, we put a physical thread on this screw and then used 20 of these screws in a large assembly, it's going to eat a lot of memory whenever we try and rebuild our assembly. So for instances like that, we want to try and use a cosmetic thread to keep the number of graphic triangles in our models down to a minimal. But if, for example, we're creating a display piece for 3D printing or for doing a high quality render, we would want the physical thread to be present. And for this example, we'll create a physical thread. To do this, we're going to go up to Hole Wizard, hit the drop down, and select Thread. Now for this first box here, the edge of the cylinder, that's the edge you want the thread to start. So we'll select this top edge right here. And you see it's automatically going to go with a 1/4-20 thread size. But as you see, it's continuing into the part, like so, and it's also abruptly stopping right there. So we'll just hit OK so you can see what happens here. You see we have this awkward stop point, and also it starts cutting into the shoulder portion of our bolt. We don't want either of those things to happen. So we'll right click and go to Edit Feature, and we're going to select Offset here, and we'll set our offset to be 0.15 inches. Let's see, it's going in the incorrect direction. It's going upwards and we want to go down, so we'll simply hit reverse direction. So now the thread is starting before it hits the physical part, which is what we want. And we have to set an end condition. We'll set it to blind, and we'll keep it set to 1/2 inch, because you see it's ending here in the undercut, which is also what we want. So this will give us a nice clean start and end point. So now we'll hit OK, and we have our thread for our shoulder bolt. The next feature that we're going to create is the socket slot on the top of our head. We're going to start by creating a center hole, So we will go to our hole wizard, and we will set our standard to ANSI inch with a fractional drill size selected for the type. And for our size, we're going to select 5/32, which is going to be the size of the Allen key used for screwing and unscrewing this bolt. And for our end condition, we'll set a depth of 1/8 of an inch and hit OK. And we want to make sure it is set to depth up to the shoulder. So basically this is saying the depth before the hole starts to converge inward at the tip of the drill bit, which is different from the depth up to the tip, which is the total depth of the hole. Okay, and now for our position, we'll select this tab and select the top face, and we're just going to line up the hole with our origin and click once to put one in, and then hit the green checkbox. So we now have our hole. Now we need to add our hex cut. So we'll select the top face and create a new sketch. And let's go normal 2. And we're going to select our polygon and select the center point of the origin and just extend it outward like so. Hit escape and select one of these vertical edges, and we're actually just going to create a vertical relation and hit OK. This prevents the polygon from spinning, so it's now locked in this orientation. It can still be resized, but we're going to define that with a dimension. So we'll select our Smart Dimension tool, and you could select opposing edges, or you could simply select this reference circle here, and we will set our diameter to be 5/32, the same size as the hole. And we'll hit OK. And we'll do a extruded cut. And for our depth, we'll go 1/8 of an inch and hit OK. Now the last step in creating this feature is to create a little chamfer for the top of our hex cut. So we're going to create a new sketch on the right plane, which, as you see, runs through the corner of our polygon, like so. So we will go normal 2. And we're actually going to change our display style here and change it to hidden lines visible, so we can see our hex cut. And we'll create a new sketch. First thing we're going to do is create a center line, because we're going to do a revolved cut to create this chamfer. And now we're just going to create a simple little right triangle. And we'll set the angle here to be 30 degrees and the top dimension to be 0.02 degrees. And our sketch is now fully defined, so we will exit our sketch and go to Features and select Revolved Cut. Again, we're going to keep the setting to blind with a 360 degree cut, and hit OK. So now if we change our display style back to shaded with edges, we see that we have a nice chamfer there, which will make getting the hex wrench into the screw much easier. Our last feature that we're going to add are the simple little notches that we see in the heads of shoulder bolts and socket-headed cap screws, so they can be physically turned by hand. To do this, we're going to open up a new sketch on the top face of the screw, and we'll go normal 2, and we're going to create a center line that runs downward. Hit escape, and now we're going to create a simple triangle like so. And we want the two edges here of our triangle to be symmetrical to the center line. So we have a few options here, but what we're going to do is hold Control, select both lines and the center line, and just simply create a symmetric relationship. And hit OK. So now as we move one line, the other one moves with it. OK. And we'll add some dimensions here. So we'll create a dimension from our origin to the hypotenuse line, and we'll set that to be 0.235 inches. The length of the hypotenuse, or the base of our triangle, is going to be 0.04 inches. And the height of our triangle is going to be 0.02 inches. So now we will exit our sketch and create a new extruded cut. And for our condition here, we want to set it to be up to next. So it will be up to the next surface it contacts, which is down here, this chamfered face here. So we will hit OK. And now we need to pattern this notch around our head OD. So what we're going to do is go up to Circular Pattern. For the feature, that Cut Extrude is already selected. For the direction, we'll simply select the outer diameter. And for the number of instances, we're going to set it to be 160. And we'll hit OK. So this propagates that notch all the way around the head of our shoulder bolt. Okay. And the very last thing that we're going to do is set our material. So we'll go up to here to Material, right click, go to Edit Material, and we will simply pick plain carbon steel for our material and hit Apply and Close. And our shoulder bolt is now complete. This concludes our quick tutorial on modeling a shoulder bolt in SolidWorks. I hope you've enjoyed the tutorial. If you did, please be sure to hit the like button and subscribe to get notifications about future tutorials from the channel. And also, if you have any suggestions for videos you want me to do in the future, be sure to let me know in the comment section below. Thank you and have a great day.